Hello, everybody. Welcome to the session on creating your first app using XAML. I'm Harini Kannan. I'm a program manager with the developer experience team in Windows. As part of the DevX team, I'm one of the PMs who's responsible for delivering the UI platform, of which the XAML framework is a part of. Specifically, I own components like the XAML input stack and the XAML application model stack. So during the presentation, if you see me gravitating towards some of these topics a little bit more, that's kind of where it's coming from. Before I start this session, I want to set a little bit of context on what the session is not going to be about. This is not a session that's going to focus on what's new in XAML. Tim Hewer had a session yesterday that had a lot of detail around that. This is also not the session where I'm going to talk about how to port your Windows 8 apps to 8.1. That's a session that Paulita handled yesterday. If you missed those sessions, I highly encourage you to go and check them out online. Once I get my sticker to work, yes. So this session is primarily going to be a little bit of an introductory session into how to go about creating store apps that use XAML. As part of that, I'm also going to touch upon a little bit of concepts and nuances around terminologies in XAML with the new Windows 8 store and Windows 8.1 store model. If I don't digress too much, I hope to get this done by the first 10 to 12 minutes, and then we're going to jump in and start building an app from scratch. Great. So let's get started with discussing a little bit about what are some of the characteristics that actually make up a store app that uses XAML. The most obvious characteristic is going to be the fact that the UI for your app is going to be written in XAML. XAML, as you all probably already know, stands for Extensible Markup Language. Back in Silverlight and WPF days, the word XAML used to refer just to the markup that you used to create UI in a declarative fashion. Starting from Windows 8 onwards and going on in Windows 8.1 as well, the word XAML actually refers to a lot more than just UI. It refers to the entire XAML framework and the stack we have built as the backend to actually create store apps. So a XAML app has UI and XAML. It also has its logic or code behind written in C# or VB, or you can even use C++. One of the reasons why C++ is now available to you is the fact that XAML as a framework used to be a managed framework back in Silverlight and WPF, but starting in Windows 8 and 8.1, it's now completely native. We have implemented the entire XAML framework model in C++. The third and probably arguably the most interesting aspect in the context of creating Windows Store apps is the fact that XAML is packaged as part of Windows. XAML ships with Windows. What this means is that as long as you have a Windows 8 or Windows 8.1 OS installed in your device, you do not need anything more to create or build or deploy or even use a XAML app. You don't need plugins. You don't need anything more. You just need your OS, and XAML, the framework, ships with Windows. Because we are a part of the Windows runtime, you as app developers have full access to the complete suite of thousands and thousands of Windows runtime APIs that you can take advantage of to create fully integrated experiences with the Windows OS level subsystem components. For example, you can create store apps in XAML and take advantage of using, integrating with the search experience. You can integrate with share, settings, devices. You can also integrate with thousands and thousands of non-UI and non-XAML WinRT components like geolocation, sensors, accelerometers. So all of these things are available for you as part of the Windows runtime library. All Windows Store apps, as well as XAML apps, are optimized for all methods of input. Basically, what this means is that any device that is used to interact with your PC is going to be referred to as a pointer. It can be touch, mouse, or pen, and all of these are going to be surfaced in the form of a pointer message, and the API for which are going to be pointer events like pointer pressed, pointer moved, pointer released, and so on. Nick did a session yesterday, and I think which deals with a lot more detail about how to optimize your app for all modes of input. The concept of mouse left button down, handling different types of mouse inputs separately from touch, separately from pen, those are obsolete as of Windows 8 and 8.1. All you have to do as app developers is handle these pointer events, and your app is now usable with any type of input device. All Windows Store apps are also designed to be fast, fluid, and responsive. The fast and fluid nature comes from the fact that we have a lot of built-in smooth scrolling and zooming experiences, as well as all the transition animations, the Windows signature experiences of having a personality that is very typical to Windows. That's all built in for you in all our inbox controls. A point about being responsive is the fact that the Windows runtime is moving towards the async programming model. So any kind of activity that your app is doing that is going to take up time on the UI thread, it is going to be processed via the async programming model, and you probably want to take advantage of that. So we are doing this in order to make sure that the UI thread is always free so that the user can interact with your app without a lot of interruption. And this makes sure that your Windows Store app is always responsive. There is a session that is dedicated to talking about how to use async programming model. You probably want to attend that to get a little bit more insight on this. And lastly, the delivery mechanism for your store app is going to be via the Windows Store. There are some concepts around how to package your app, how to get it certified in order to be deployed to the Windows Store. I will be touching upon a little bit of all of these in the app that we create today. Yeah, hopefully we will, by stepping through, step by step, we will get to understand how to create apps for the Windows Store. So that said, what are some of the types of apps and experiences that you can create using XAML? You might have questions around, are there a specific category of apps that are more suited to use XAML? Well, the short answer is no. You can create any kind of app you want. To illustrate that point, I have captured a small snapshot of different types of apps we have in the store today. For example, we have a whole slew of productivity apps that, from Microsoft Studios, like your OneNote, Link, Maps. So even the SkyDrive, which if you attended the keynote, you probably know that it's a new modern file management system. So all of these are built with XAML. There are a whole slew of entertainment-related apps. You have high-content media apps that are built with XAML. You can create gaming apps with XAML. You can create high-fidelity DirectX drawing content, reading apps, writing apps, note-taking apps, any kind of miscellaneous apps. There are a lot of examples of them in the store today, and you can create all of these experiences with XAML. Some of you may be surprised to know that a lot of Windows core experiences doesn't work. Let me use my keyboard. So a lot of Windows core experiences actually use XAML. So for example, the PC settings page, all the UI for that, the content, as well as the search experience, the new Bing integrated search experiences with the search results UI, all of that is built with XAML today. So really, the point I'm trying to make is the fact that through XAML, we have tried to deliver this really robust, powerful, high fidelity and high performance developer framework that you should be able to take advantage of and use for any scenario that you might have in your app. With that XAML plug, let me quickly talk about what is the tooling support we have to create these apps, how you actually go about building these apps. We have worked very closely with the Blend and Visual Studio teams to create a very good tooling story, which, the designer experience, the simulator experience, all of these have been really improved in order to help you create really good store apps. While on the topic of Visual Studio, I do want to highlight the simulator tool that you can use, which is built into Visual Studio. Any type of scenario that you have that you cannot, that you cannot simulate in your development environment, you can use the simulator tool to emulate that particular scenario. So for example, this PC that I'm going to use today to build our app does not support rotation. I can use the simulator's rotation tool and make sure that I check out what my app looks like if it gets rotated. And these are some of the things that you might want to think about when you're creating Windows Store apps. Great. So that said, I'm going to stop talking, and we're going to actually start building an app. So the app that I'm going to build today is going to be a little meta. I'm going to build a Build Conference Hub app. Basically, this app is going to be a place where people can come and check out what's happening in Build Conference and get some data around whatever is happening around the Build Conference. If you attended some of the sessions yesterday around what's new in WinRT or what's new in XAML, you probably have heard a lot about the hub pattern that we have introduced in Windows 8.1. That's a kind of the new pattern that we've introduced, which helps you represent heterogeneous data in your app. So any different types of content can be represented together in one bucket in this kind of hub pattern. If you've not seen it, I can quickly show you what it looks like. So the Bing applications, all of them use the hub pattern. A typical application for this is the Bing News app. If you see this, the app has a good landing page where it shows a nice hero image, as we call it, which sets some context into what the app is and highlights some of the important aspects. After that, you have a lot of sections. There's a Get Started section, there's a Top Stories section. All of these sections, as you can see, also contain different types of data represented. For example, this Top Stories section, you have images and text, and the Sources section, you have a list of data. So these kind of experiences you can build using the hub pattern. So we are going to do something similar today. I'm going to build an app that uses the hub pattern, and we're going to create sections for different types of data. I'm going to build a section that shows agenda. I'm going to build a section for location and announcements, keynotes. So all these kind of things that we're going to build today, we're going to use the hub pattern. Great. So let's get started. I'm going to boot up Visual Studio. I'm using 2013 Express. You can also use the other SKUs available, like the Ultimate or the Professional. For the purposes of this app, the Express is sufficient. It's available for you for free. File New Project to start a new project. As soon as I start up, you see that I'm choosing a Visual C# XAML app. You can also choose Visual C++, or you can even use Visual Basic for your app. For the context of this app, because I want to start something from scratch, I'm going to use the blank app template. You can also use either the grid app, the hub app, the split app templates. These are built into Visual Studio and available for you. Depending on the scenario that you have for your app, you might want to use any of these templates. The hub app is a new template which contains the hub pattern. So let's go ahead and get started. I'm going to name my app the Build Conference Hub. And I create my app. There. So as soon as I create the app, the first thing that I want to talk to you a little bit about is the Solution Explorer. Because we created a C# app, I'm going to have a CS_proj file and a solution file. There are a couple of properties to it and references. Inside references, you can see that all you need is .NET and Windows. The point that I mentioned before, that XAML is shipped with Windows, that's exactly what it means. All you need is a reference to Windows. The SDK contains all the references you need to develop XAML apps. So great. We'll come to assets a little bit later. The topic that I want to talk about a little bit in detail before we build our app is these two files, the app.xaml and app.xaml.cs files. Together, they represent the application object. The application object is your entry point into the app. This is the place where your app, where the system first looks at when your app is launched. The application object is also the place where you want to declare any of your global resources. So any app-level scope resources that you want to access from anywhere else in your app, this is the place you want to declare them. So they might be style-related, they may be string resources, they may be anything, and this is the place you want to put them in. The application object also does two other important functionalities. One is the fact that it maintains the lifetime of your app. By lifetime, I mean 3 states. Your app can get into 3 states when it is active. It can be, as soon as it is launched, it gets into the activation state. At some point, when the user stops interacting with your app and brings it to the background, it gets into a suspension state. If the user does not return back to your app after a while, it gets terminated. There is a key difference between the suspension state and the termination state. Your app is notified when it gets suspended. The app is not notified when it gets terminated. So when your app does get suspended, you get a suspending event. If you look at app.xaml.cs, you can see that inside the constructor, there is a handler for the suspending event. If you look inside it, a key functionality that is done here is to make sure that you save the state of your app that is currently in before you process anything else, so that when the user comes back to your app, if it did get terminated, you can load the state that the user was in before it got suspended. So let me show you what that looks like very quickly. So in suspending, you can see that this is the place where you save the state. And on launched, this is the first event that is fired. And here you can see that As soon as the root frame is initiated, there is a check for finding out if the app was terminated, and you can load the state that you actually saved during suspension over here. There is a fourth important part to application object, which is the fact that this is the place where you can handle all your unhandled exceptions that are occurring anywhere in your app. So all you have to do is inside your application class, say this dot unhandled exception, and handle it over here. So what this does is make sure that if there is an exception that is occurring at any of the native layers or anywhere in your app, this is the final place where it all gets bubbled to, and this is the place where you can handle it gracefully. So great. So now that we have done a little bit of exploration into what the application class is, let's actually look at our landing page, the landing UI, and start creating our UI. So you can notice that this is a basic blank app template, so I don't have anything in my template. It just has a basic grid, and then I can start creating my UI. The one thing that I want to do before I actually start creating UI is to show you the design. Go to the devices window. This is a handy tool that you can set certain things in the designer without even running your app. For example, you can set your designer to be at either 100% or 140%, 180% DPI, the resolution scales, which are different for different devices. And once you set that, now your designer is able to show you what your app looks like at different resolution scales. Even without running your app, you can check it out. So these are some handy tools here. The one thing that I'm actually going to change is change the theme. There are two themes available for you. You can either use a dark theme, which is the default, or the white theme. It basically means that the dark theme is the default. As you can see, the background is going to be dark, and your text on top of it is going to be light, and the light theme is going to be just the opposite. Because it's easier for me to present with a light theme and easier for you to see it, so I'm going to switch to a light theme. As soon as I switch here, you see that the designer updated itself, but there was also a warning which tells me that all I have done right now is change it in the designer. I have to actually change it inside app.xaml if I want this theme to be set at runtime. So let me go ahead and do that. So I open app.xaml, and here I set requested theme equals light. So as soon as I do that, the warning is gone, and now my app is ready to go with the new theme. Great. So let's get started with building our app. Like I said, we're going to build a hub app. So I'm going to start with a hub control, which is a new control we have introduced in Windows 8.1. I'm going to name it, because it's always nice to name your controls. And the first thing that I want to create within the hub control is a header for it, so that my app's name is shown at the top of it. So let me create a header. I just say header, and I say bold, because that's what my app is about. Great. So now I have a hub control, which is going to be serving as my content control. That will hold all of my content within this app. You can see that the designer automatically updated with the data that we just created. Great. So let's go ahead and start creating sections into this. Like I showed you with the Bing News app, the first section that I'm going to create is a nice hero image section, which represents a full bleed image of some kind of context for the app. So let's create a section. I am saying hub section. I give it a name again. I call it hero image section. The hub control by default is a horizontally stacked control, as all of our usual controls are. Because of this, I'm going to set different widths to different sections, because all of these are going to be horizontally stacked against each other. So I'm going to set a nice big width of 1,000 pixels, because I want my image to be rendered nice and beautiful across the screen. So I've created my first section. Now I have to add an image to this section. There are a couple of different ways of adding an image to your section. One way would be to just add an image control, set a source to it, and give it the image source that I want to set to it. I'm going to do it a little different this time, because I want to make sure that my image is rendered as a full bleed image for the entire section. So the way to do that would be creating a background for my section and actually applying an image as the background for that section. Let me show you how to do that. So I'm going to say hubsection.background, and inside that, I'm going to use an image brush, and inside its image source, I'm going to set it to the image that I want to be displayed over here. Right now, I don't have an image in my application folder, so I have to add an image to my application folder and then reference it from here. So let me do that. I have an image in my desktop. I'm just going to drag and drop it inside my assets folder. So as soon as I drop it, I can now reference it. Sorry, say assets, hero image.png. So as soon as I do that, we can look at the designer, and you can see that the image has now been added as a full bleed image for the entire background of that section. There's one thing that I want you to notice within the assets folder over here. You can see that all the other assets over here, the logo, the small logo, those are the things that were built into the Visual Studio template. They have a qualifier attached to them which says scale -100. This qualifier signifies that this asset has to be used for a resolution scale of 100 or above. So if I had different image assets for different resolution scales, for example, if I had a different hero image asset for scale 140%, for example, what I have to do is add all of those assets into this folder and name them using this convention. Just say hero image.scale-100, hero image.scale-140. And if I set that, all I have to do in my image source is the same thing that I've done here. Just refer to it as hero image. The framework automatically takes care of getting the right resource for the device that the app is being displayed at and rendering it for you. There is an improvement that we have done from Windows 8 to 8.1 in this particular field, which is the fact that at runtime, if your app if your resolution scale for the device that your app is running in is changed at runtime, maybe by the user manually changing it, or if they drag your app from one desktop to another one which has a different resolution scale, now the framework automatically takes care of rendering the right resources and retrieving the right resources for that resolution scale and rendering it and at runtime without you needing to do anything as a developer or the app user needing to close the app and reopen it or anything like that. It just automatically takes care of it for you. So great. Now we have created the hub section, the first section of the image. Let's go ahead and actually create the first data section, which is going to be an agenda section, like I said before. So this agenda section is going to hold some data related to what are the sessions available for a particular date in the build conference. So let me create a section. Similar to previously, I just say hub section, :name, agenda. And I set a width. Great. So I want to create headers for this section because I'm going to have multiple sections after this. I'm going to have a location, I'm going to have an announcement section, I'm going to have keynote, etc. So one way to do a header would be to merely set the property over here like we did with the hub name. Another way to do it would be to specify it outside like a hub section.header and use any content element that you want to display over there. I'm going to use a text block that just has a text that says agenda. Actually, I'm going to call this agenda section. Great. So now I've added the header. Let's look at it here. What it shows is I have added the first hero image section, and now I have an agenda section with a header. It looks nice, but I want to make it even better. I want to make my header look better. All I have to do is set some styling elements to it. I can change some properties to this text block and make it look different. I can set the properties like font size maybe, or whatever it is. A font family. I don't get IntelliSense, so let me do font size and say 40 maybe. So these are different things that you can set at the text block itself. There are other ways to do this, and one of the main reasons why you want to think about other ways to do this is the fact that in this context of this app, like I said before, we are going to create multiple sections, and all of these sections are going to have headers. In order to make sure that I define properties that are common for all of these header sections, I can create styles and then refer to them using the static resource markup extension available for me from the XAML framework. So what I can do is create a resource dictionary, and in that resource dictionary I can define a style and then apply that style to any element I want within that context. Let me show you how to do that. I'm going to remove this, and within the context of page, I'm going to create a resource dictionary which says page.resources, and inside that I'm going to set a style with a key of custom title text style. This is the unique identifier for this style that I can use within the context of this page. I can also define resources in the context of any content element. For example, I can say grid.resources, and it will apply to anything that follows within that grid. Or I can have global resources, which I can define inside my app.xaml, which is going to be application.resources. The target type is the UI element to which this style has to be applied to. In this case, I'm going to apply this to a text block, so I'm going to use that. And I'm setting some properties that are relative to this text block element, so that I can, when I apply the style, these properties will be changed for that UI element. So now that we have our property defined, let's actually access it. In my text block, I'm going to say style, and then I'm going to use the static resource markup extension, which basically tells the framework that this particular style has been defined in a resource dictionary. Go pick it up from there. So here you can see that there are different styles that are coming up. The IntelliSense actually pops up with a lot of standard styles, as well as the custom style that we just created. In Windows 8, you used to have the concept of standard styles.xaml, which was available with the template. That has now been changed to make sure that all of the styles that are applicable for UI elements are now packaged within the framework itself. So you don't need to worry about that. So you can apply any of these styles to your text block. I'm going to apply the custom title text style that I just created. If we look at the designer, you can see that the style got applied here. The font size and the font weight for this agenda header got changed. Great. So now that I have created my header, let's actually create the content. Like I said, the content is going to be a place for the user to pick a date, and then all the dates, all the sessions for that date are going to be displayed under it. Let me hide this. So in this section, the first thing that I want you to note is the fact that it's all enclosed within a data template. The reason for doing this is to make sure that your app is performant and responsive. Because I have enclosed this content of this section within a data template, the framework knows that it has to render this section only when it is in the viewport of the user. So because I'm going to have multiple hub sections which are panning across pages, I don't want my app to start up with loading all of this content at once. That's going to hold up the thread, and it's going to be very slow at startup. So what I'm going to do is declare them inside a data template, and this tells the framework that don't render it right now, render it when it is panned into view. So here, inside this data template, we have the stack panel, which is the content control. I'm asking the framework to render a date picker and a list view control stacked vertically with each other. A date picker is a new Windows 8.1 control that we've introduced, which gives you the option of selecting a date, a month, or a year. And a list view control is one of the modern collection controls that we introduced back in Windows 8, and it's being improved in Windows 8.1. The other modern collection controls that are available for you include grid view, group grid view, semantic zoom, these kind of controls. The advantage of using these controls is the fact that you can, a lot of built-in experiences like transition animations, the way it is brought into view, the visual states for them, the selection modes, all of those signature Windows experiences are built into these controls, and you can just leverage it. So inside this control, the list view control, you can see that all I'm doing is setting an item source for this control. Because we don't have this data that we want to display inside this control when we are actually creating this control, I am telling the framework to bind to an object that will be available only at runtime. So by using the binding markup extension, I'm telling the framework that this is please defer rendering this item until runtime. We will be so here I'm binding it to an object called sessions, and each sessions object is going to contain title and timings for multiple sessions within that date. So this is basically the content of our section. Let's actually work on building the content that is going to be displayed in this content right here. So for that, I go back to the code behind for my main page file, which is the main page.xaml.cs. Right now, it doesn't have much. And here's the place I'm going to actually load my content to be displayed in that UI. The first thing I need to do is actually create the objects that I have bound to. So let me create those classes. Here I'm creating two classes. One is for the agenda item and then an agenda group class. The agenda item is each individual item. I have a title and a timings for each session that has to be displayed. And then I also have an agenda group, which is a session date and a collection of agenda items for that date. Now that I have my classes and the objects, the next thing I need to do is actually load data into these objects. There are a couple of different ways you can do that. The way that I'm going to do today is actually I have a session data.json feed that I'm going to load. I'm going to read from that feed, and I'm going to parse it as text. From that, I'm going to load the JSON objects and populate this object that I've created here, so that at runtime, all of this gets mapped to the UI that we just created. So let me actually let me put the session data.json file that I have inside my folder, application folder, so that the compiler can pick it up at runtime. So I go to Visual Studio, I just drop it here. Let me show you what this feed looks like. It's a simple feed. All it has is dates and sessions. Each session has a title and a timing. This maps exactly to the UI we created as well as the objects we created. The one thing that I need to do in order for the framework to know to pick up this file is to go to properties for session.json and tell the framework that it needs to compile this as content. If I don't say that, this file is going to get ignored. So if I set it as content, now when I build this application, this file will get built and it will be put in the folder where my application can access it at runtime. So now I have my file, I have my classes. Let's go ahead and create the functions that is going to load this data. So this function, I'm going to call it as getGroupAsync. There are a couple of different things that this function is going to do. Let me step through them one by one very quickly. So it takes in a value of date, which is going to be a string date. Here I'm also loading the file that I just added. It's a session data.json. You can see that the naming convention I've used is MS-Apex. I'm using this because I'm going to use the WinRT API get file from application URI async and load that file. In order to do that, I want to make sure that this file is actually put inside my application package. So these are WinRT APIs that I'm using. Once I load that file, I am reading that file as a text file. And once that file is read, I'm using some JSON objects and parsing that file as a JSON feed. And then I'm loading it into the classes that we just created. So once I have an instance of my class, I can now load it such that all the sessions and titles and timings are now loaded into my object at runtime. The one thing that I want you to note is that all of these operations are async operations. These are all file input-output operations which are going to slow down your UI thread. So it is all these WinRT APIs are by default async. And because they are async, they have to be awaited. And when you are awaiting an async function within your method, the method also has to be an async method, which is why this is also an async method. There are some nuances around, sometimes when this is not always going to be true. You want to attend that session about async programming model to know a little bit more detail around all these nuances. Great. So now I have my data. All my sessions have been loaded. The one thing that I'm doing here is to filter the sessions based on the date that the user picked. Once I have filtered it, as soon as I hit a match, I just set the data context for my agenda section with that match. This is the most important part where your the data that you just loaded into your objects is now being matched to the UI you created. So when I'm setting the data context, it's basically telling the framework that this is the group, basically the agenda group that we created here is what you should be using when you are rendering this list view, which has a binding to the sessions object. So once I set the data context, it's just going to pick it up, and my UI is going to render with this data when it is available. Great. Now I have my session object. All I have to do now is actually call this function. So let's go ahead and call this function. So the date picker control is where I'm going to have the event handler to call this function, because there are two instances where I want to display this data. The first instance is going to be the time when the app is actually loaded, because we are in the middle of the build conference, so there are sessions available right now. The app is going to get loaded with the current date of today. So I want to make sure that the sessions for today are visible to me when I load the app. So let me handle a loaded event for the date picker control. And I also want to handle another event, which is the date changed event. This will be fired when the user selects a different date. So on these two actions, I want to make sure that I display the data that I've loaded. So because I created a new events, Visual Studio automatically created snippets for me. So inside the date changed event, let me add a quick snippet. Here you can see that the thing that I'm doing here is merely to get the date that the user picked, format it based on the string that I already have in my JSON feed, and then pass it into my getGroupAsync function. This is an async function. It is being awaited, so I have to make this an async method. Once I do that, it gets corrected. Similar to that, I'm also going to do a loaded function. So here you can see that all I'm doing here is actually getting the current date and then passing it to the function. Similar, again, await, so I have to do an async. Great. So now our agenda section is built. Let's run the app and see whether all of this works. Great. So now I have my hub section, the first section of my full bleed hero image. I have my header. I also have my agenda section with a header. And because I handle the loaded state, my app loads with the current sessions available for me. It is rendered inside this list view. You can see that the title and the timings have now been rendered correctly because of the bindings that we created. And you can see the visual states. For example, I can select, and all of this is built in for me. I don't have to do anything. If I change a date, I should have new data available for me. Do note that when I change the date and the new data is being displayed, all these transition animations that are happening while rendering this new data, it's all built into these list view controls. Great. So now we have built the agenda section. It's arguably the most involved section in our app today. The other sections are going to be a little more simple. So let's go ahead and build an announcement section, a keynote section, and a location section, and see what are the experiences we can add to this app. The next section I'm adding is an announcement section. This section has a similar setup to the previous section. I'm having a header. You can see that I use the same style for the header that I already created, which is the purpose for which we created that style in the first place. And inside the data template, I'm going to use a web view control. A web view control is the control you use to render HTML content inside your XAML app. So basically what I'm doing here is setting a source to the web view control to a HTML page. The framework will automatically go to the source, obtain the HTML content, and render it within this control. We have done a lot of improvements to the web view control. There is a deep dive session on that as well. You might want to attend that to understand what are the nuances around the web view experience. I want to add a keynote section. Here what I'm doing is actually displaying a media element which contains an MP4 file from a URL, basically the channel 9 URL. I have used the MP4 file from the keynote we had yesterday. And I want to show it as a media element so that the user can actually view what happened at the keynote. One thing that I want you to note here is the fact that we have our transport controls enabled equals true. So this is the new API that we have introduced in Windows 8.1 for the media element control. With this API, setting it to true is all you need to actually obtain the suite of built-in transport controls to display on top of that media element. You do not need to create your own transport controls for play, pause, full screen, all of those elements anymore. So great. So I've created this control now. Let's run this app and see how all of this comes together. So I have my heroes image section, I have my agenda section, I have announcement, and I have keynote. Notice that this is the web view. This is the HTML content. It's rendered seamlessly within the XAML app. I'm able to interact with it. There's also a keynote section. You can see that as soon as I mouse over it, you're able to see all the different controls over here. These are the transport controls. You can play, pause content. You can do full screen. You can go back to your app. You can do all of that stuff from the context of your XAML app. Great. The next section that I'm going to create is a location section. In order to use a location section, the way I'm going to do it is by actually putting in a Bing Maps control, which contains the location for the Moscone Center, and just show what it looks like in this particular location. A Bing Maps control, you can add a Bing Maps control to your XAML app by using the extension SDK that is provided for you. I already have installed the extension SDK for Bing Maps in my system over here, but there are a lot of MSDN documentation that you can just refer to in order to know what you need to get set up in order to access this. The first thing that I'm going to do is add a reference, and inside that I'm going to look at the extensions. You can see that the Bing Maps for C# extension SDK is now available for me as an extension. I can just add it. There is a dependency for this, which is the vclibs dependency, so I'm going to add that as well. Once I add that, there is a little warning that comes up. Basically, why this is coming up is because the Bing Maps extension SDK as well as the VC++ runtime libs have a lot of, it has an architecture dependency because they are C++ components. So I have to go to Build, Configuration Manager. If you can see here, I'm setting, right now my platform is set to any CPU. I need to set it to a specific architecture in order for this to work. So I'm going to choose x86 for this context. The warnings go away, and now I can actually use my extension SDK. So what I'm going to do in order to use this extension SDK is create a local reference to this custom control. The way to do that is going to be, you're probably familiar with this. I just say XMLNS and create a variable that I can use later. I'm going to say using bing.maps. Now I have a reference. I can use this Bing Maps variable in order to access this custom control anywhere within my app. So I'm going to go ahead and add a location section. So inside this section, this is similar. I am having a header, and inside this data template, all I am doing is referring to that map, a map control, which is a custom control. And because it's a custom control, they have extended our user controls, and they have created multiple different APIs within that control. You can see that credentials is an API for that custom control, and then there is a zoom level, and there are map centers and locations and things like that. So for credentials, there is a Bing Maps API key that you need to provide in order for your app to get access to this Bing Maps control. The way to do that, so this is going to be a string resource. And what I'm going to do is actually declare the string resource as an app scoped resource so that I can access this anywhere within my app. So what I'm going to do is similar to the way we created the style. I'm going to go to app.xaml and actually create an application resource. Application.resources. Oops. And inside that, I'm going to say, give me a string resource. It's a string resource. The key, which is a unique identifier, is going to be the Bing Maps API key, and I'm going to have the string for it here. All I have to do right now is reference Bing Maps API key, and I can use it anywhere in my app. Great. So now we have the Bing Maps control. I've added a location. Let's go ahead and run this app and play with this control for a bit. String is magic. Yep, there we have. So you can see that the location control has nicely rendered a Bing Maps control over here, and it's centered around the Moscone Convention Center, which is the location that I provided for it. The one thing that I want you to note here is the fact that during the course of building this app, I've created these different sections. I've created a section which contains HTML content. We are rendering some media content. And the location section, the Bing Maps, is actually a DirectX content that is rendered over here. And on top of this DirectX content, you see these controls. These are XAML controls. So what is happening here is basically a XAML app that contains HTML content, it contains media content, it contains DirectX content, which contains XAML content on top of it. So all of these things exist seamlessly and composed beautifully together inside your XAML app, and all of this is available for you for free. Great. So now that I have created these different sections, I'm going to stop creating sections. I'm going to actually show you some of the new commanding patterns that we've introduced. One of the key commanding patterns is, of course, the app bar. There are a couple of changes to the way app bar works in Windows 8.1 when compared to Windows 8. The app bar, for those who don't know, is basically the control that comes up when you swipe up or swipe down from the edge of your screen. For example, I go to Start Screen and I swipe from the top. I get a nice little bar which contains the commands for the app. This is the typical commanding pattern that is the signature Windows experience. So in order to create that experience, I'm going to create an app bar control. So you can see that I'm creating a bottom app bar. I'm not using app bar as a control anymore. That was an experience that was there in Windows 8. It still exists. It exists as a primitive in Windows 8.1. A command bar is something that we have introduced new. It contains primary commands and secondary commands. A command bar's primary commands are those commands that appear at the right of the screen. Secondary commands are those that appear at the left of the screen. This is in relation to the UX guidelines about how to develop your apps. So I'm going to have a primary command, and I'm going to use an app bar button, which is again a new control in Windows 8.1. It's a simple command. It just has a like button. These are new items that you can do with the app bar button. In order to have glyphs appear in your command app bar button, you just have an API called icon, and you can just set it. Now that I've set it, you can actually see that it's going to give me a like icon. So I'm going to have a small event handler that handles the click of this button. What I'm going to do inside this button is basically just say, hey, thanks for liking. So I'm going to display a message dialog, and it's going to be a modal dialog. I have an await, so I have to do an async. Great. So now that I have created this, let's run this. So you can see I have all of my content. I'm going to swipe up from the bottom, from the top, and I have my app bar come up. I just press on like, and it gives me a nice message dialog, which is modal. Thanks for the like, and as soon as I close it, it goes away. So all of these commanding patterns you want to take advantage of in creating Windows Store apps. There is one other thing that I want to add before we get finished with our app. It is the fact that in order to illustrate how to integrate with some of your Windows subsystem components, I'm going to create settings for this app in the context of this app that is going to actually appear in our settings flyout. So currently, when we run this app and I actually invoke settings, you're going to see that there's a standard settings of permissions, and that's about it. You can actually create new settings in the context of your app and populate it inside of this command bar over here. So the way to do it would be, actually, we have introduced a new control, which is a settings flyout control. I can add new item, settings, and there is a settings flyout control available for you. This is new in Windows 8.1. We didn't have this in Windows 8. What this does for you is actually create a settings flyout which has the properties of light dismiss. It has the properties of height and width and transitions and animations and how it integrates with the settings charm, all built into it. All you have to do is create a settings control. I'm going to customize this control based on what my app is. I'm going to call it an options setting, and inside that, I'm going to change some of these setups. So the header, I'm going to call it as manage updates. I don't want capital A. Anyway, so the body, I'm just going to take away this text block, and I'm going to make it a toggle switch control. And I can set the header of a toggle switch control. This header is actually an interesting property that we've introduced. In almost most controls, even a text box, you can now create a header and just set it to a value. It's going to appear as a label on top of your control. So you can just say download updates automatically. So this is going to be my toggle switch, and this is what it looks like. Now, we have created the flyout, we have created the settings control. I have to add this to the settings commands of the Windows when the settings charm is invoked in the context of this app. The way to do that would be to go to your main page. As soon as the app is launched, I'm going to use the WinRT API for actually invoking settings. Windows UI application settings.settings pane. I'm going to get for current view, which means that I'm getting the settings pane for in the context of this app. And I'm going to handle the event for commands requested. So as soon as I do that, inside this event, I have all I'm doing here is basically creating a command for options, which is the flyout that we just created. And when this option is invoked, I want to show my settings flyout. Because I'm declaring it as a settings flyout, all of the animations and the way it appears from the side of the screen and goes away when you dismiss it from anywhere outside of that settings flyout, all of this is automatically taken care of for you. Let's run this app, and I'll show you the settings that we just created very quickly. So we have our app. I'm going to invoke settings. You see that the options that we just created is available right now. Click on options, and the options flyout that we just created comes in for you. I can touch anywhere, and it gets slide dismissed immediately. Great. So with that, we come to the end of our app. I have created a couple of different components for you with the app. The one thing I want to show you before we switch back to our presentation is the package.appexmanifest file. This is an important file that you want to pay attention to, which has concepts around packaging your app for the store. You want to make sure that the description and the names of your the app, etc., are taken care of here. The supported rotations is a field where you can configure whether your app has to be rendered when the device is rotated. So if you don't want your app to be rotated when the user switches to portrait mode, you can just say, I want to support only landscape rotation, and be done with it. The minimum width by default is a 500 pixel width. You can opt in to a more minimum than that, which is a 320 pixel width. Sarah McDevitt has a session today which talks about in a lot of detail around the different sizing of your apps and how to handle the different sizes. I would strongly suggest that you attend that session to get a little bit more details. The tile is the logo of your app that appears in your start screen. You can update your tile to be a live tile. The way to do that would be to actually specify a URI here and say, how often you want that tile to be updated with live data, and that URI can just push the data over here, and it'll poll every half an hour or 6 hours, depending on how you configure it over here. You can declare a lot of assets over here, the logos and etc. The splash screen. You want to pay attention to all of this. I want to show you what's going on in capabilities. In capabilities, this is the place where you actually set whether your app is going to opt into some of these Windows runtime APIs. For example, we have used the Bing Maps API. In order to actually enable your app to take in the current location of the user using the GPS chip, you can opt into the WinRT API for location, and this is where you declare that. Some other declarations include whether you want your app to participate in the search experience, or if you want your app to participate in share target, if you want your app to have a file picker option in it. So this is the place where you actually declare these experiences and actually opt into that. Content URIs is specific to web view controls. I'm going to skip this. And within packaging, it's very simple. You have to make sure that your package name is clear, and if you make sure that your version numbers are currently updated. So once you actually deploy your app to the store, you want to make sure that every time you deploy a new update, your version numbers are updated so that it gets picked up correctly. So these are some of the things that you want to make sure that you pay attention to in the context of creating an app package for the Windows Store. With that, I'm going to switch back to our presentation and get concluded. So we learned a lot of things today from our app building. We saw what are application classes and what are the different concepts that you need to know in order to create an application object. We created the UI. We used a lot of XAML controls, non-XAML controls. We had the modern collection controls, primitives. We added a lot of things. We saw how to handle styling and themes. We saw how you can actually opt into dark and light themes and how they are reflected in your app. We use the binding markup extension to create a runtime binding to your data model. We worked with a lot of non-UI Vinarti components like storage files and file input-output operations and how to handle those. We added a lot of non-XAML content. We added HTML content. We added DirectX content in the form of a custom control. We added all of that. Yes, we worked with extension SDKs. We added a Bing Maps extension SDK to our app and actually used a custom control from that extension SDK. I showed you how to use commanding patterns in the form of app bars. We worked with settings. We integrated our app with the settings charm. We handled a little bit of display diversity. I showed you what you need to know in terms of your app rendering at different resolution scales, how to handle. I didn't go into a lot of detail around sizes and how to handle that because Sarah is going to have a very deep dive discussion on that. I don't want this session to become redundant with that. And of course, I showed you a little bit of detail around some packaging concepts that you need to know in order to actually deploy your app. There is definitely a lot more to actually creating a Windows Store app. You want to make sure that your app is fully accessible. Premalini had a session yesterday that went into a lot of detail around how to build accessible apps in Windows 8.1. If you missed that session, I highly encourage you to please take a look at it online. You want to make sure that your app is globalized. What that means is basically that if the audience for your app is going to be people who are non-English speaking, you want to make sure that you localize your string resources for those languages. You want to make sure if you want to opt into all these other capabilities, you want to explore them, you want to add them. You want to make sure that your app is maximized for performance. Kiran has a session later today in the same room, which is going to talk a lot about how to maximize performance. We have done a lot of performance improvements in XAML and Windows 8.1. WAC actually refers to the Windows App Certification Toolkit. Please take advantage of it. You want to make sure to run this toolkit against your app package once you create it. And when you run it, it gives you all the, it's a wizard that takes you step by step through your requirements for getting your app certified for the Windows Store. And yeah, it's not it. There are so many different more concepts to actually creating Windows Store apps. But I hope that I've given you a little bit of insight in creating a Windows Store app, just going and creating it step by step through this experience of building this Build Conference Hub. Please let me know if you have any questions. With that, yeah, the session is pretty much come to an end. I hope I haven't